Okay, next topic is algebra of vectors. I already written some points. First one is multiplication with a scalar. So if a vector A is multiplied with a scalar lambda, we will get lambda A vector. Okay, so if this is vector A and lambda is positive, then lambda A will be like this. If lambda is negative, this is the scenario. This is the multiplication by scalar. That's it. Okay, clear? Now if lambda positive, what will happen? If lambda is positive, lambda A and A are in same direction. If lambda less than 0, they are in the opposite direction. It is very clear. One more point I need to add, which is if lambda equal to 0, then what will happen? What will happen? You will get A and a 0 vector. Are they collinear? I have said A and lambda A are collinear. Are they collinear? Yes, they are collinear. Any vector and 0 vector are collinear. Why? Because 0 vector can take the direction of any vector. So A and 0 vector have same direction. So that is, you need to understand. Say you take A and 0. Are they collinear? Yes, they are collinear. What about B and 0? They are also collinear. So can I say A and B are collinear? No, that's wrong. A and 0 are collinear vectors. B and 0 are collinear vectors. Any vector and 0 vector are collinear vectors. There is no doubt in that. But A and 0 are collinear, B and 0 are collinear does not imply A and B are collinear. Okay. For example, you take I cap and 0 vector and J cap and 0 vector. Are they collinear? I and J? No. So I hope you understood this concept. They can ask question like this. A and B are collinear vectors. A and B collinear. A and C collinear. So can I say B and C collinear? No. Why? If A is 0 vector, then these two conditions will be satisfied, but the third condition will not be satisfied, need not be satisfied. Okay. So I hope you understood this. Otherwise, they should say that A and B and C are non-collinear vectors. Then it is true. Sorry, non-zero vectors. Then it is true. Okay. Okay. So this is multiplication by scalar. Now what is next? Addition of two vectors. You know this very well. Addition of two vectors. There are two laws: triangle law of vector addition and parallelogram law of vector addition. In triangle of vector addition, I have considered a triangle and two sides of the triangle are taken as two vectors, vector A and vector B, such that B is placed in such a way that the initial point of B is at the terminal point of A. Like that you should place. Okay, initial point of B is kept at the terminal point of A. In physics you use head and tail, those things. Here we use initial point and terminal point. Okay. Then the third side can be written as their sum, A plus B. Okay. So that's the concept. This is triangle law of vector addition. You should do it in the proper way, otherwise you will not get. Okay. So this is A, this is B, this is C. So what is AB plus BC? AC. That is the concept here. Okay, AB plus BC equal to AC. But understand one thing, if I take A in the opposite direction, B here, things will change. Sir, how it will change? That we will discuss after some time. But understand the logic. Okay, AB plus BC is AC. Now we don't need any figure to understand this equation. Why? AB, BC. So what is left? AC. Very simple. A to B you reached, then B to C you reached. So ultimately you started from A and reached C. You don't need this figure to understand this equation which I have written. Okay, it's very easy. I can simply write PQ plus QS. What is it? PQ plus QS. PS. That's it. Okay. Okay, so that is triangle law of vector addition. Clear? Understood? So I need to add two vectors. Let me take an example here. This is vector A and this is vector B. How can I add them using triangle of vector addition? So what should I do? What should I do? I have A here, then I should place the initial point of B at the terminal point of A. Can I do it in the opposite order? Yes, I can do it in the opposite order. There is no problem. First, let me keep initial point of B at the terminal point of A. That is, this one I should keep here. Okay, so this one I will take and keep here. That's what I am telling. Okay, so let us do that. So I kept here. So this is P. Is it okay? Yes. Can we move vectors like this? Yes. Why? Because we are dealing with the free vectors. So this is, what is this? This is A plus B. Okay, what I did, initial point or initial point of B is kept at the terminal point of A. Okay, now what happens if I do it in the opposite order? Say like this, I kept A here, no, B I have. What I am going to do, I am keeping the initial point of A, I am keeping, this is B. Okay, I am keeping the initial point of A at the terminal point of B, like this. Is it correct? Sorry. Like this. Is it correct? Yes. Then what should I do? I should join them. Then I will get this. I think okay. Like this. See this? This is B plus A. Both are same. B plus A. Are they equal? Are they same? This vector A plus B and this vector B plus A. Are they same? Yes. Okay. So both are correct. That's how we should add two vectors using triangle law of vector addition. Just keep the initial point of one vector at the end point of the other, then just add them. Okay. Clear? Now, what is parallelogram law of vector addition? Actually, we don't want to study this parallelogram in very detail, because it's just another way of telling or another way of using triangle law of vector addition. Parallelogram law of vector addition. What should I do? You have a parallelogram, then you keep two vectors as initial vectors. Okay, two adjacent vectors, vector A and B are taken as two adjacent sides of a parallelogram such that they are co-initial vectors. That means same initial point. Then the diagonal. Okay, take it as then the diagonal starting from their initial point is the resultant or sum of A and B. Okay, this is A plus B. Proof is very simple. How we will prove this? Just mark B here, that's it. Then this is triangle of vector addition. Okay, very simple. Or you can go with this is one A, B plus A plus B, both are same. Okay, this is parallelogram law of vector addition. Okay.